We have learned about the moments. In this video, we want to show that these moments are interrelated, and we can approximate one moment, let's say a mean of g of x and y, when x and y are two random variables. We want to use approximate these using some other moments, so and we'll find an expression for that. So the objective is to estimate mean of one function of two random variables using joint moments, some of the joint moments, and this is just an example. So if you consider a function of g of x and y, in general, we can use many different approximation. For instance, we can expand it using a Taylor series expansion or any other expression, and you could have the expression of the error of the approximation. For example, using Taylor series expansion of order mn, you could write this expression, and here I wrote the expansion around the mean of x, and this one is mean of y. So I approximate the function using these two moments, but remember that this is another function, so we want to convert these to real values with random variables. So if we substitute these x and y with random variables x and y, so we get an approximate random variable, and then we can calculate expected value of both sides. So we substitute this pair of x and y by x and y, so we substitute here and here only. And remember that this part is the derivative of the function x and y, n times with respect to x, m times with respect to y, and then once you calculate the derivatives, then you substitute x and y by mu x and mu y. So this is calculated using the mean of x and y and the derivatives of x and y about mean of x and mean of y. So now we substitute here, and then we take we find an expression for these. Then from this resulting expression, which is this one and this one, we take an expected value of both sides. So then we find this expression. So the expected value of this guy will become the central moment of x and y about the mean of x and mean of y. So you get simplified. So this is the moment of order mn and m, and these are the derivative of your function around that. So you see that you could use all the moments of order less than n and m in order to have an approximation for the mean of g of x and y. So again, this is the definition of the central moment. Basically, is mean of this part after you replace x and y by the random variables.